Okay, so now I have found all the probabilities of the different colors. Now what should happen is if I add all the fractions together, all the decimals together, all the percents together, I should get that 100% because that's like the total of the likelihood of all of it. They're separate, okay, but if I add them together, I should get that whole, which was 100%. So I'm going to go ahead and do that to make sure that it's correct. Now, when we add fractions, we always add the numerators and keep the denominators same. You have to have a common denominator. So when I do this to get my totals, I think I'm just going to go ahead and use this one, right? Because this is the one with the common denominator. So don't get confused with the 1/5. I'm going to add these because they all have 25. I'm going to go ahead and zoom in at this point so you can see the fractions a little better. Okay, so I've run out a little, well, I think I can do it. So 25. All I'm going to do is add the numerators. 6 plus 4 is 10, plus 7 is 17, plus 1 is 18, plus 2 is 20, plus 5 is 25. And 25 out of 25 is 1 whole. So I know that I have my fractions are all correct because I should get a 1 whole. Now I'm going to go ahead and add the decimals. Remember, you add the the hundredths place first, and then add the tens place. So 4 plus 6 is 10, plus 8 is 18, plus 4 is 22, plus 8 is 30. So 0, carry the 3. So 3 plus 2 is 5, plus 1 is 6, plus 2 is 8, plus 2 is 10. So 0, carry the 1, and bring down the decimal. So 1 whole. Perfect. Now, if I add these up, it should be exactly the same because it's the same numbers, except they're written as whole numbers, so it would be 100%. So we're good. We did everything correctly. Okay, so now lots of times what they like to ask at this point is like, which one would most likely occur? So if you were to pull one marble out, what's most likely going to happen? Well, that's going to be the one that is your largest percentage or your largest fraction. It's easier if you can compare the decimal with the percent because if it's in fraction form, you got to compare the numerators with the common denominator. And if you've already simplified them, then you're going to get confused. So if you can look at your percents, is which percent is largest? Okay, and it's blue. So you're most likely going to pull a blue out of the bag. That's what the theory says. Now there's one that's pretty close to blue, which is green. So these two are really close together. But what's most likely to occur? Blue. Blue, maybe even blue or green. Okay? Now what's least likely to occur is probably your pink because it's their smallest percentage. So and one that's also not likely to occur is orange because they're very close to that 0. Now, is anything really like 50% or more? No. So these are all very smaller percentages below 50%. You have a lot of different colors in the bag. Okay? So this, if they did this as an experiment, you probably are not going to see your theoretical probabilities. So you have lots of different options. Okay, so let's go ahead and get some advanced probability questions. It's probably as hard as it gets. So probability that you get a green or blue. All right, if you see this or in probability means to add. Okay, so all you're going to do is add the probability of green to the probability of blue because it does not matter whether you get a green or a blue. It just matters if you get one of those. Okay, so go back to our probability. Probability of green was 6 out of 25, so I'm going to write that here. And I'm going to add it to the probability of blue. And probability of blue was 7 out of 25. Denominator stays the same. Add the numerators. 6 plus 7 is 13. So 13 out of 25. Okay. Now I could change that to a percent or a decimal. That fraction is in the simplest form, that's why I boxed it. I could change that to a percent or a decimal if I choose to, but we're just going to leave it in fraction form. Okay, so now let's do blue or yellow. So I'm going to go get the probability of blue. Remember, the probability of blue was 7 out of 25. We just got that one earlier. I'm going to add it to the probability of yellow because I see or. 4 out of 25 for yellow. And 7 plus 4 is 11. Yep. 11 out of 25. We can't simplify it, so I'm just going to box it. Because remember, it doesn't matter if I pick blue or yellow, it's just one of those options. So there's 7 blue and 4 yellow in the bag. So there's 11 of those total. It's really all you're doing. Okay, pink or brown. Pink was down here, 1 out of 25. And brown, I'm pretty sure it was 5. I'm going to use the 5 out of 25 because we need a common denominator to add. So 1 plus 5 is 6. 6 out of 25. Can't simplify that one as well. Okay, now they love to trick you with these not questions, okay? But probably that's not blue. There's a couple different ways that you could do it. The most simple way is to just add up all the ones that are not blue, okay? There's another way you could do it. You could take your total and subtract what is blue to get the not, because we know that to get not, we always subtract at some point. So remember we had 25 total marbles, and then how many are blue? 7. So if we take 25 and we subtract 7, we would get 18. So there are 18 that are not blue out of 25. Can I simplify that? No, I can't. So that is our answer. Now, lots of times what you're going to see is you're going to see it written like this. Sometimes people like to write the answer like this. 1 minus, and how many were blue? 7? 7 out of 25. Because this is the whole, and that's what we did. Remember, we took 25 and we subtracted 7 to get our 18. So that's what you're going to see. You're going to see the 1 minus what is. Because 1 is the whole. Remember how we decided that if we added everything up, we would get 1? Okay, so if we take the entire likelihood minus what should happen, we should get the not. You're going to see it like that. But this 1 right here is equivalent to 25 out of 25, which is really what we did to get that 18. 25 minus that numerator, because this right here is 1 as a fraction.